Hello, and happy winter to everyone. Today we're doing a lesson on multiplying to solve equations. All right, so it's a little bit of a review. We've done some of this before, but we're going to be using some little trickier equations this time. So I'm going to write a few points here, and so if you entered that in your composition book, that's great. Make sure it's in the back of your table of contents, and here's your title, and these are some points that I want you to write in, okay? So one thing we are going to do is we are isolating the variable using division. Now when we use division, you may remember that term, the multiplicative inverse, okay? So I'm going to write that down here, and it's a good word to make sure you have in your notebook. And it has another name, you might remember. It's called the reciprocal, right? And that's pretty much a term for flipping a number, right? So if I have the number 5, every whole number is automatically over 1. You can make a whole number a fraction by putting the fraction bar and putting a 1 on the bottom, right? So if I want to take the multiplicative inverse or the reciprocal, I flip it. So I have 1/5, right? Let's say I have a fraction such as 2/3. Then my multiplicative inverse or reciprocal would be 3/2, okay? So that's what we'll be using today when we work with our problems, all right? So you can pause that video if you need more time, write that in. And I know this is a little bit of a review. We've done some of these before. So example 1, I'm going to take 10n, which equals 90, right? So we want to isolate the variable. We're going to use division. This is my coefficient here. So I am going to divide, actually, let's look at this for a minute. So this 10, remember, is over 1. As I said before, all whole numbers can be a fraction by making it over 1. So if we want to take the reciprocal of that, it's 1/10. So down here, I'm going to show 1/10 times 10n equals 90. And whatever we do to one side, we need to do to the other side of an equation, right? So that is going to eliminate this coefficient here, which we want to because we're trying to find what does n equal in this equation. So we can cancel out these 10s, which leaves me with n. And then remember every whole number again over 1. I can put that there if that helps you remember to cancel these. But 10 goes into itself 1, and 10 goes into 99, right? So n here in this case is 9. And many of these problems you can actually figure it out in your head, right? You would probably know, oh, I know 10 times 9 is going to give me 90. But we're learning the process here of how to do these equations. And of course, when we do an equation, we want to do the check. The check goes back to the original equation, all right? I'm going to just say, all right, we had 10n, so 10 times 9, because remember, any number next to a variable is multiplication, which equals 90. Okay, is that correct? Yes, this is where you actually are checking it. Remember, I've asked you on complicated ones to do that math, make sure that you're right, because this isn't just something, you're going to write down and say, oh, I know what that is. Okay, good. Now, let's do a little bit more of a complicated. So you can pause this if you need more time. I'm just going to move along to example 2 here. All right, on example 2, we have x. I'm going to come down here. Divided by -5 equals 4, all right? That looks a little more confusing here, but what can we do with this? Well, if I want to see what my fraction is here, because here's the denominator, what is the numerator? It's an invisible 1. So I'm going to write this out so you can see this. So I would take that fraction, negative 1/5 times x equals 4, okay? That's really what that is. But you know, in algebra, they like to show some things a little shortcut way, right? So they might get rid of that 1 and they might put the negative here. Negative could be out here. All right, now we have a fraction, so we can use the reciprocal of that, right? I'm going to take that sign with me when I do the reciprocal. So I'm going to flip it. So I'll have a negative 5 over 1, right? Times a negative 1 over 5, x. And that, now what I did to one side, I have to do to this side. 4 times negative 5. Again, I don't have to put it over 1 here. I will just to show you, but you really don't need to because that's over 1. All right, so let's look. So now we can cancel these 5s out. Remember our rule for multiplication and division. If the signs are the same, the answer is positive. So this will keep it a positive x. Here, I can put that over 1. 4 times 5 will be 20. I have a negative times a positive, so it'll be a negative 20, okay? So there's a lot of things to remember in these little equations. You have to keep track of fractions. You have to keep track of your signs, all right? Let's do the check. Check, I'm going back to the original equation here. I'm putting a negative 20 for x. So negative 20 divided by negative 5 equals 4. Again, my rules for multiplication to division. If the signs are the same, the answer is positive. Signs are different, negative. So I have two negatives here, which will make a positive. 5 divided into 20 is 4. Is that correct? Yes. And I don't have to put those negative signs there, but if you wanted to, they should be up at the top of the number. You can do that, okay? Great. All right, I'm gonna do maybe one more. So I'm gonna switch my board. Well, I'll just erase this board, I guess. Do that. We'll do example 3 here. All right. So this one is negative 3x equals 12, right? So here I have a multiplication. So I'm going to take, and this is like 3 over 1, right? So I want to take that, the reciprocal of that. So it's going to be a negative 1/3, right? Times negative 3x equals 12 times negative 1/3, okay? Here again, I can put this 3 over 1, and I can cancel those 3's, and a negative times a negative is a positive, so I want to keep my variable positive there. I can put my 12 over 1 here. I can cancel my 3, and I can cancel divided into 12, which will be 4, right? So now I have a positive times a negative. So this answer will be negative. Always look at your sign first when you're getting your answer. And now 4 times 1 over 1 is just going to be 4, right? Okay, let's see if that checks. Go back to the original. Negative 3 times x, which is now negative 4, equals 12. Does that work? Yes, because my rule in multiplication is the signs are the same. The answer will be positive, right? So I have a positive 12 equals a positive 12. There we go. All right. So let me show one more because these fractions, this is pretty simple in terms because we don't have any fractions in it. But I want to show one more with a fraction. Okay, so this would be, was that 3 and this is 4? I don't remember now. Yeah, okay, here we go. All right, so this problem is x divided by 2 equals a negative 8, all right? So again, we want to extrapolate that fraction. So that's a 1/2, right? So if that helps you, to do it this way, that's fine, you know? Then you can see, oh, right away, the reciprocal of that is 2 over 1. So I'm going to multiply 2 over 1 here, multiply 2 over 1 here, right? And so then I'm going to cancel these 2's. So I just have x. I can put my 8 over 1. Maybe I should have made this a little bigger, to show you that. And what is negative 8 times a positive 2? Well, first, it's negative. I got my sign. Now 8 times 2 is 16. Okay? So now we'll do our check. Go back to the original problem. I have negative 16 divided by 2 equals a negative 8. Is that correct? Yes, because a positive 2 with a negative 16 would be a negative answer. And 2 divided into 16 is 8. So negative 8 equals a negative 8. All right? So there you go. And I hope that helps a little bit in terms of figuring out these fractions. This homework will have many more negative problems with fractions. So if you have any difficulty, let me know. And thank you for paying attention and joining me in this lesson. All right, have a good night. Bye-bye.